Hello friends, welcome to this second video on cross correlation. In the first video we saw about the definition of cross correlation and the properties of cross correlation. This video will try to explore on a problem on cross correlation. The problem goes like two random process x of t and y of t are given to us, and the value of x of t is taken as a cos omega t plus theta, y of t is taken as a sin omega t plus theta. We have a and omega to be constants, and theta is going to be uniformly distributed random variable in the interval 0, 2 pi. The objective is to find the cross correlation between the two functions x and y. Now we know the formula for cross correlation as from the definition of the last video, Rxy of t comma t plus tau, which we can denote as Rxy of tau, is going to be expected value of x of t product y of t plus tau. So now let us copy paste the value of x of t from the given problem as a cos omega t plus theta product. Now we want y of t plus tau. What we have in hand is y of t. So what has to be done? Wherever we have t, we replace this as t plus tau. So this gets replaced as t plus tau. Hence the second term becomes a sine omega t plus omega tau plus theta. So now we have this to be equal to a and a over here are going to be constant. A and a makes it as a square. We know the property that expected value of ax is going to be a times expected value of x. In the case that when a constant is multiplied with a random variable, the constant is unaffected. It comes outside the expectation, and the expectation operator operates just on the random variable x. So a and a square being constant, are going to be taken outside. So we have expectation only to the cos and the sine term, which involves theta, the random variable over here. For convenience sake, let me rewrite this as sine omega t plus omega tau plus theta in the first term, product cos of omega t plus theta as my second term. Now, since we have theta to be uniformly distributed random variable, we know that expected value of g of theta is going to be integral from a to b g of theta fx of theta into theta, f theta of theta into d theta. What is this f theta? This is nothing but the marginal function which has been given for the uniform distribution. So what is for our uniform distribution? Our f of theta is going to be 1 divided by b minus a. The interval of definition for theta is going to be from 0 to 2 pi, in which case I have this as 1 divided by 2 pi minus 0 for 0 less than theta less than 2 pi. So from over here I have my f of theta to be equal to 1 divided by 2 pi. So now in place of this f of theta, I can replace this with 1 by 2 pi. So the expectancy for the condition of theta over here has to be integrated with the functional input and the product of marginal value. Now let us go apply this property to this expectancy, in which case we have this to be equal to a square. Expectancy now gets replaced with integration of sine of omega t plus omega tau plus theta into cos of omega t plus theta. So this is going to be my g of theta, which is already given as an input. This has to be multiplied with an f of theta, which is going to be 1 divided by 2 pi for me, into the integration has to be carried out with respect to theta between the interval theta varying from 0 to 2 pi. So this is going to be the value which has to be integrated. Now a square 2 pi is a constant that can be taken outside. So I have a square divided by 2 pi, 0 to 2 pi sine of omega t plus omega tau plus theta into cos of omega t plus theta into d theta. Now we can see that we have a product of two trigonometric functions that cannot be integrated directly. So we will go for equivalent trigonometric identity, which can convert this into addition or subtraction forms. We will try to recollect that sin A cos B is sin A plus B plus sin A minus B divided by 2. So in place of our A, we have this to be equal to omega t plus omega tau plus theta, and in place of B, I have it to be equal to omega t plus theta. So I have two quantities sin A and cos B now for substitution. So let us substitute this to be equal to A and this to be equal to B for us. So on substitution, what happens over here? This becomes sine of A omega t plus omega tau plus theta plus B. What is going to be B over here? Omega t plus theta plus sine of A minus B omega t plus omega tau plus theta minus B makes it as minus omega t minus theta, and this has to be divided by 2. 2 is a constant, so let me pull it outside. Integral from 0 to 2 pi, this has to be integrated with respect to our d theta. So already we have an a square divided by 2 pi outside, so this can be furthermore simplified. Now we notice that this can be rewritten as a square divided by 4 pi. Let me split it into two integration. 0 to 2 pi sine of omega t and omega t makes it as 2 omega t plus omega tau plus you have a theta here and a theta here, so it is becoming 2 theta over here d theta. This is going to be my term number 1, and this is going to be my term number 2, which I am going to separate it in my next slide as, so a square divided by 2 makes it as 4 pi integral from 0 to 2 pi. What happens over here is this omega t cancels off with this omega t, and this plus theta cancels off with this minus theta, leaving you with just one term omega tau. So we have sine of omega tau into d theta to be my term number 2. Okay, so now let us simplify this term 1 and term 2 separately and then finally add both of them. Now working with the term 2 as we have done over here, this is going to be a square divided by 4 pi. Now we can notice that the integration is to be carried out with respect to which variable? D theta. But sine, does it contain an angle theta inside it? No. Since the theta is missing over here, this sine omega tau is entirely considered to be a constant and it can be pulled outside the integration, allowing you to integrate d theta alone between the integral 0 to 2 pi. So this makes it as a square divided by 4 pi sine omega tau d theta on integration gives you theta between the limit 0 to 2 pi. So we have it as a square divided by 4 pi sine of omega tau, and this gives me 2 pi minus 0. This 2 pi can be cancelled off with this 2 pi for 2 times of the quantity. Hence we have this as a square divided by 2 sine omega tau. So this makes my term number 2. Now let's come on compute the evaluation for our term 1, sine 2 omega t plus omega tau plus 2 theta. So we will copy paste this in the next slide as term number 1, a square divided by 4 pi integral from 0 to 2 pi. You have sine of 2 omega t plus omega tau plus 2 theta into d theta. Now we have to recollect the simple formula for integral sine theta d theta is going to be equal to cos theta. And when I have sine 2 theta, it will be cos 2 theta divided by 2. The same thing happens over here. We have sine of 2 theta, hence the final answer will be cos of 2 omega t plus omega tau plus 2 theta divided by 2, and this has to be applied between the limits 0 to 2 pi a square divided by 4 pi. So now this constant makes it as a square divided by 4 2s are 8 pi. The upper limit makes it as cos 2 omega t plus omega tau plus theta takes the upper limit 2 2s are 4 pi. minus theta takes the lower limit cos of 2 omega t plus omega tau plus 0. So this makes it as cos 4 pi plus theta. We know that cos 4 pi plus theta is the same as 4 theta. Why it is so? Because we have all silver tea cups. When you rotate one time, you cover 2 pi degree. When you cover twice, you cover 4 pi degree. When you have 4 pi times plus theta, it falls in the first region, and over there all the terms are going to be positive. So you are left out with cos 2 omega t plus omega tau for your 4 pi plus theta. Coming to the second term, you have 2 omega t plus omega tau plus 0. 0 is nothing but the initial line. It hasn't moved anywhere but stays over there. Hence we have the same term as cos 2 omega t plus omega tau. Now these two terms cancel off each other with the positive and negative sign, leaving you the value for the term number 1 as 0. So when we move on to check with our term 1 plus our term 2, we see that term 1 has now vanished and it has become equal to 0, allowing us with just our term 2 value. Hence the final value for your cross correlation now becomes a squared divided by 2 sine omega tau. Thank you.